My dear students, in the previous video, I have started the topic 12th chapter in the second volume, Discrete Mathematics, and I introduced the topic and I gave the definition of binary operation, and with an example I have defined it. And in the previous video, I explained n in the set of integers. In the set of integers, in the set of natural numbers, n, addition is a binary operation on n. I explained addition is a binary operation on n. But subtraction is not a binary operation on natural numbers, I explained. But subtraction, now I am going to give one more example, but the subtraction is a binary operation. Subtraction is a binary operation on Z, because we know that 5 minus 7 equal to minus 2, which is not in n, but which is in Z. Minus 2 is not in n, therefore minus is not a binary operation on natural numbers. But negative natural numbers are included in the set of integers. You know, positive numbers and negative numbers are the members of the set Z. Therefore, minus 2 belongs to Z. Therefore, subtraction is a binary operation on Z. Similarly, multiplication. Multiplication is a binary operation in all the sets, because n multiplication is a binary operation. Multiplication is a binary operation on n, Z, Q, n, Z, Q, and R also. Because any two natural numbers you multiply, this again 5 into 4 equal to 20, which is in n. Negative multiplication also in Z. 5 into minus 3 equal to minus 15, which belongs to Z. Therefore, positive multiplication, negative multiplication of the members of Z. Therefore, multiplication is a binary operation Z. Similarly, rational numbers, multiplication of two rational numbers is again a rational number. Multiplication of two real numbers is again a real number. Therefore, multiplication is a binary operation on n, Z, Q, and R. Like that. Then one more algebraic operation, division. You see, the operation is binary or not depends upon the elements of the set, given set, is that n whatever it may be. According to the elements of the given set, only the operation is either binary or not, we have defined. That is, the division operation. Division. It is, for example, division of two natural numbers is not a natural number. 4 by 3 is not in n. Similarly, it is not in Z. It is not in 4 by 3. Division is not in Q also. It may be. Division is not a binary operation. Division is also, because why it is not in Q means m by n is in Q and n should not be 0, which is a definition. But in our Q, 0 is there. 0 belongs to Q. So if it is n is 0, it should not be, the fraction should not be in Q. Therefore, if the denominator may be 0 because 0 is in Q, so this fraction, if it is 0, it is not in Q, therefore division is not in Q also. Division is not in Q. And R also, because real number set also, there is real number set also 0 belongs to R. 0 belongs to R. So division of any two real numbers P by Q, Q should not be 0. If Q is 0, this is not in. If Q is 0, P by Q, if Q is equal to 0, it is not in R. Therefore, division is not a binary operation in N, Z, Q and R. Whereas division is binary over Q minus Q except 0, R except 0 and C except 0. Because 0 should not be, for the division operation, 0 should not be the element of the set. In complex numbers also 0 is an element. Therefore, division is a binary operation. Division is a binary operation on Q except 0 or except 0 or minus 0, that means, and C except 0. So, division is a binary operation on Q0 minus 0 or minus 0 and C minus 0. And these are the things which are given as a tabular column in your book. You can refer. Whatever the binary operation on what sets, it will be the binary operation is given in your textbook as a tabular column. You can verify it and you see. Now, closure property. I am going to give closure property of binary operation. Closure property. Star is a binary operation on S star S to S. Star is a binary operation on S cross S to S. That is, star is a binary operation because A comma B belongs to S star S, and on operating star, A star B belongs to S. According to the star operation star, A star B belongs to S. Then star is said to be a binary operation on S. Star is a binary operation on S, we have seen. See, a set, a non-empty set S together, and also if it is so, if a set and a binary operation is a binary of in set S means S is closed. S is closed under star. This is the binary operation. S is closed under star. This is the closure property of a set. N is a non-empty set. N is the example. N is the set of natural numbers. Natural numbers. Addition operation is a binary operation. Therefore, N is closed under addition operation. Similarly, what is it? Q is closed under multiplication, because multiplication is a binary operation on Q. Therefore, multiplication on Q, binary operation, X is multiplication is a binary operation on Q. Therefore, Q is closed under N. Similarly, division operation. What is that? Division is binary on R minus 0. Therefore, R minus 0 is closed under division. This is R slash 0 is closed under division. These are the properties. These properties are called closure property. This is the definition of closure property, and these are the examples of closure property. Therefore, a set is said to be closed according to a given binary operation. It depends upon the elements given in the set. With that set, the elements of the set only, we can define whether the operation is closed or not, or whether the operation is binary or not. Okay. Now, Now I am going to give an example, algebraic structure. Now I am going to give a definition for algebraic structure. Algebraic structure. A non-empty set S. A non-empty set S together with a binary operation star on S. Yes, non-empty set S together with the binary operation star on S, then star on S is called binary structure, algebraic structure. If star is a binary operation on S, then set S comma star. S star is called algebraic structure. Algebraic structure on S with respect to star. S star is an algebraic structure on S with respect to the binary operation star. A non-empty set together with the binary operation star on S. If S star is a binary operation on S, then S star is called algebraic structure. Example. We can say addition is a binary operation on Z. We know addition is a binary operation on Z because two integers, sum of two integers is again integer. Therefore, addition is a binary operation on Z. Addition, subtraction, and multiplication. All these three operations are binary operations. These three operations are binary operations on Z because addition of two integers is again integer, subtraction of two integers is again integer, multiplication of two integers is again integer. Therefore, plus addition, subtraction, and multiplication of these three binary operations are defined on Z. Therefore, the set is Z and the plus minus into these operations, three operations together with the binary set, non-empty set, integer set. This Z comma plus minus into is called an algebraic structure. It's called an algebraic structure. Algebraic structure on Z. This is Z plus is closed, plus is closed, minus is closed under Z, and multiplication is also closed under Z. It is an example for algebraic. That is, one or more binary operations can be explained on a set. We can find two or more binary operations on a same set to form a structure. N plus is an algebraic structure. There is only one binary operation here. But n minus is not an algebraic structure because minus is not a binary operation. N minus is not an algebraic structure. It is not an algebraic structure because subtraction is not a binary operation on n. Therefore, it is not a binary algebraic structure. But n plus is an algebraic structure. Because addition is a binary operation on n. Multiplication is not binary, therefore it is not an algebraic structure. This is examples of algebraic structures. Now I am using the closure property I am going to solve one example given in your book. Example number 12.1. Examine the following operations. Example 12.1. Examine the operations. Binary operation. Examine the binary operation star is closed or not. Star is closed or not in the given two problems. One, A star B. First problem is A star B equal to A plus AB minus 5AB. A plus AB minus 5B square. A comma B belongs to Z. See, A and B are two elements of Z. If A and B are two elements of integer set of integer, then this sum and the subtraction with B square is closed or not. Is this operation satisfies the closure property on Z? Yes, it is closure because A addition operation is binary on Z, subtraction is also binary on Z. Addition, subtraction and multiplication are binary on Z. Therefore, AB is in Z. A plus AB is also belongs to Z. Negative integer with B square. B square belongs to Z. And a negative integer with B square is also belongs to Z. Therefore, totally A plus AB minus 5B square belongs to the set Z. Therefore, star is closure property is satisfied in Z. Therefore, with the binary operation star, Z is closed and star. Closure property satisfied. Closure property is satisfied. This is the problem, first problem given in your book. And one more problem, second one is second problem. A star B equal to A minus 1 by B minus 1, where A comma B belongs to Q. See, in this operation, AB belongs to Q. Since B belongs to Q, it means if B equal to 0, if B equal to 1, if B equal to 1, B minus 1 becomes 0, denominator becomes 0. If it is the case, A star B does not exist. If B equal to 1, B minus 1 is 0. In this case, therefore, in this case, A star B does not exist. Does not exist. Hence, closure property is not satisfied in Q. In this case, in this problem, closure property is not satisfied in Q because B equal to minus 1, because B1 is also in Q. If B is 1, because 1 is in Q, B minus 1 is 0. If B minus 1 is 0, denominator 0 becomes A star B not defined, undefined. If B minus 1 is 0, A star B is A minus 1 by 0, it is undefined. Therefore, this property fails. That's what it is. Closure property fails in the given Q. I will stop here. We will continue in the next video. Thank you.